we'll go back to an Excel file now. Okay. Any other questions on that before we keep moving forward? We're okay with all that? No questions? Okay. Just out of curiosity, I mean, if you want to type it in the chat, you can Zoom. But everyone in the room, how many of you have any of you had, and whatever you would classify as like an in-depth knowledge of Excel or use of Excel prior? Couple people, some shaky hands out there. Yeah.
I have a question about the count. Is that just to measure like frequency?
Yeah, so it is basically going to always give you a count. So it will always give you a frequency of the observations that fit the criteria that you tell it. Yep, yeah, it'll always give you essentially a frequency or a count. The question there, sorry, was if COUNTIFs always gives you a frequency. And the short answer is yes, it always gives you the count of whatever number of observations fit the criteria that you told it, or that you put into that function. Okay? Any questions on that? All right. So now that we have these frequencies, we want to create a table, right? Or a histogram, because we started with continuous data, we forced it into bins, now we have our frequencies. So what you'll do here, select these labels we created, and here I made these labels pretty short. Probably if we were going to do this a lot better, we would do something like this and make sure that people knew where the equality was. But for the sake of time, we don't have to type all this out. I'm just kind of giving you a fresh idea of this. And usually you'll already have the labels somewhere, so you can probably just copy paste them, right, from like a Word document. But for now, we'll just keep it simple. Select your labels, hold Control, and once again, I think on a Mac, anytime I say Control, probably is hold Command, and then select your frequencies. If that's not working on a Mac, then it probably still is Control. Most of the time, it is Command on Mac, though. So now that we have these both selected, right? Hopefully anyone have trouble getting both the columns selected. Yeah. We'll go up here to insert, and here's all of our chart options. All we want is a vertical bar chart. So you could do 2D, you can get cute and do a 3D one. You can play around with the chart title. My job here, like in this class, I'm not trying to teach you how to format things in Excel. I just want to make sure you can get the data into a graph like this, right? So on your individual assignment, when I say a graph or a table, it could be something like this, but it could be something as simple as what I'll show you here in a second is just a time series graph, okay? All right, so just insert that bar graph. Same kind of thing, if we wanted to do, I'll show you, I have a complete file over here, but I'll just show you real quick. So I have like a time series graph here just for help with your individual assignments. If you have something and it's like by year, you could also just do this time series. There, all you would have to do, select your years. Actually, I think what we're going to want to do here is just select the unemployment rate. Go to Insert. We'll do a line graph, right? And then to get the years there as labels, we would go down here, select those. Right now it's 1 through 16. We want them to be the actual years. You would right-click, go up here to Select Data, and now for your axis labels, instead of 1 through 20, you'll hit Edit and select the years. And that's kind of another graph you can create for that individual assignment as well. Pretty straightforward, right? Once you grab the data, the only kind of nuance here is that you had to select the years after the fact, which is kind of annoying. I think some of the older versions, it automatically would pick up on that. But notice if I just select both of these, and I go to insert this, it tries to graph my years here on the bottom, so we don't want that. So kind of an additional step to getting that graph to look a little bit more appropriate if you're doing just a time series or a line graph. Okay. All right, so we'll go back here. We'll move this out of the way, maybe. So we've got our frequencies. What if I wanted to do relative frequencies? What would I need to do here? If you can remember from last class. To get the relative frequencies, I just simply need to take the frequency and, remember we said it was like a proportion. divided by the total number of observations. Well, what's a nice way I could get the total number of observations? We said that was just if I add up the frequencies. So to add things up in Excel, when you just select, when you're selecting numbers, equals sum, and then just select the numbers you want to add up. So here, and there we go. Oh. I want you to be able to see this, and now it's, there we go. So I just select all the numbers I want to add up. Hit enter, and it adds them up for me. Okay. Now that I have that total, I'll just say, okay, to get the relative frequency, take the frequency, divide it by total number of observations. Okay. And now I'm just going to copy this down. What went wrong? Huh? Exactly, right? N15, yes, I do want, instead of using 36, which is the value in N9, when I copy it down, I do want to use N10, or that value of 7, but I want to keep dividing by that same total number of observations. So that cell reference of N15, I want to make sure I freeze that, right? Or put dollar signs around it. So if I put dollar signs around that, now when I copy it down, once I get down to here, it's taking that frequency of 1, still dividing it by the total number of observations. Okay? Any questions on that? So here's a point at which we can look at another Excel function, which is the count function. This has no criteria associated with it. It will just count the number of cells you select. So if I just select one cell, oh, why did it tell me 0? Oh, because there's nothing in that cell, sorry. It counts the number of cells that have data in it. So if I go like up here, it'll give me a 1. If I select 3 cells with data in it, it'll return to me a 3. So what I can do is say, well, look, I want to make sure that I got those frequencies right. So when I added them up, that total number of observations is correct. So I'll use that count function. And then I will just select the variable, right? Control Shift or Command Shift down arrow. Hit enter. And it counts the number of observations I had. Sure enough, I did everything right here because that matches up, right? The sum of my frequencies matches up to how many observations are in that data set. Now another check we can do at this, didn't want to go over that far. Another check we can do at this point is, what should the relative frequencies add up to? See someone hold a finger at 1, right? So let's select those, double check. Sure enough, we didn't make any mistakes here, right? If you see anything other than 1 here, or the sum of your frequencies doesn't match up to that count function, you know you made a mistake somewhere. More often than not, it was a mistake with your equalities, right? You forgot an equal sign, or maybe you flipped the greater than or less than sign. Sometimes that, I've seen people do that, okay? So far, so good, okay? The next thing we can do, we could do percent frequencies if we wanted to. That's not that interesting because what's the only other thing we would need to do? Multiply the relative frequency by 100, right? But another thing that we haven't talked about yet are cumulative frequencies. So what a cumulative frequency is it's the number of observations that belong to the bin you're looking at plus every bin below it, okay? So another way of saying that, I'll type this out because maybe it'll give you a good idea. So for that very first bin, well, it would be the frequency that's in the current bin and every bin below it, but there's no bin below it, so it's just going to be the number of observations in between 0 and 2500. For the second bin, cumulative, right? Cumulative, kind of like your cumulative GPA, it's every course you've ever taken. It's the number of observations in this current bin I'm looking at, plus the bins below it, which include this one here. So what it's actually going to be counting here is the number of observations between 0 up to 5,000, right? Because it's this bin plus everything below it. Does that make sense? You don't have to type these out if you don't want to. I'm not going to use them. I'm just more so using them to give you a visual of what I'm saying. Okay? sure there's no questions in the chat. So then for this next one, it would be everything in this bin plus the 2 bins below it. So this would be 0 to 7,500, so on and so forth, okay? So what am I gonna do? Well, this first one is actually pretty easy. I'm looking for the cumulative frequency for that very first bin. Notice it's just counting the same thing, right? There's no bin below it, so the cumulative frequency for that first bin will just be whatever the relative frequency was. And here, I guess I should say cumulative relative frequency is what we're going to be calculating here. But now for the second bin, it'll be the frequency of the bin I'm looking at here plus the relative frequencies of every bin below it. So I could say it's going to be the sum of these 2 frequencies, right? And then how would I find the cumulative frequency for this next bin? It's going to be the relative frequency of this bin plus the 2 below it. So if I wanted to, I'd say, okay, so I want to add these 3. And then keep on going down until I get to the bottom. What's maybe not, I don't always have someone get this, but maybe someone see, what would maybe be an easier way to do this? Yeah. Yeah, exactly, right? So instead of using that sum function, what if I said, well, I know it's the relative frequency of the current bin that I'm in plus the relative frequencies of every bin below it. Well, the relative frequencies of every bin below it would just be whatever the cumulative frequency was from the previous bin. So here I'll say it's the bin I'm looking at, relative frequency plus, oh, now it's hiding this from me, so I can't select it. Why is it doing that? Go back in here. Well, why is this being goofy? It's going to be cell what? P9. So once I get this typed in, I'll show it to you here real quick. Right? It was just taking that relative frequency and adding in the cumulative frequency. Oh, hold on. Why is it doing this to me? Well, you can kind of see it selecting that red sauce behind there. I don't know why that box is so big right now. But I'm taking the relative frequency of the current bin and adding to it the cumulative frequency of the previous bin. So now when I copy this down, it just continues that process. This relative frequency plus the cumulative frequency of the next bin. All the way down to the very last one, which why is the cumulative relative frequency 1 when I get that final bin? What am I really saying there? Yeah, I'm adding up all the relative frequencies. It should be 1 when I get to that final bin. What proportion of the data is in the very maximum bin and every bin below it? What's all the data, right? Hopefully it's 1, okay? And you could do the same thing with cumulative relative percent frequencies if you wanted to. I think that's maybe a little overkill, but you could, right? It would just be use the relative frequencies, multiply them by 100, and use the same process, okay? Any questions on that? Because I know it's a little bit trickier. Okay. And we could do the same thing. We could use our labels, create new labels, and then insert a cumulative relative frequency table. Right, it's the same process. I could use these labels, select the cumulative frequencies, insert. Now, a lot of the times with these cumulative relative frequencies, instead of bars, a lot of people will just use a line graph. You kind of see it starts out pretty high and approaches 1 and finally gets to 1 once we get to that last bin, right? But that's really inserting that. I'm just going to delete it to kind of take it off the screen here real quick. It's the same process as when we were creating the histogram, right? Just insert and then select the type of chart you want, okay? Any questions on that? Make sure there's nothing in the chat. Okay. No questions? Want to see like another cell again, or like if you have something that's not working too, feel free to ask me, and then we can kind of figure it out together. No? Okay. So let's go back here. And I have some of this. You can graph the relative frequencies if we wanted to. You could use a line graph instead of a bar chart. I don't know why you would want, I mean, I don't know. I think the bar charts makes more sense. We talked about these cumulative frequencies. The book calls them ogives. I have no idea why. Now let's talk about a couple other graphs that we could do. All right, so where are we at in time? All right. Well, I already showed you this one, right? I already showed you the time series graph, how we do that. So let me go up here in the completed one. I didn't know if we would actually get a chance to get through this week. So this isn't in the blank file, but it's in the completed file. It's got some additional tabs, just so I can kind of show you some stuff in class. I don't expect you to like work along with this one. It's pretty easy. It's just creating graphs. I already showed you how to do the time series graphs here. We selected the data, insert a line graph. Then we went down here, right-clicked, hit select data. Then for the axes labels, we hit edit and selected the years. I thought it was actually interesting. This is wild. This is an aside, but this is what you get from me. So notice like the unemployment rate this year, like it's crazy high right now, but it was so low the first 3 months that the actual average isn't quite as high as the annual unemployment rate back in the recession we had in 2009. So things aren't good, but they haven't been good before, not even that long ago. So that, I don't know, that was somewhat interesting. But the other thing we can do is create scatter plots. So here I've got some data on healthcare expenditures and life expectancy. So you might think like, what's the relationship between these two variables, right? If a country spends more on its health, hopefully people live longer, right? So what I can actually do is grab these two variables, just select them, and then I go to insert. You'll see this guy down here, this chart type is scatter. And I can do a scatter chart, and it kind of shows me, if I try to draw a line through this, what is the relationship? If I look at this, maybe it's a slightly increasing line of best fit here. So maybe as you spend more on your health, you do live a little bit longer. But there's also some really weird outliers, like this country here is spending way more than any other country, but they have like the second lowest life expectancy, which, do you want to take any guess at what country that is? Yeah, right? And so you got to think about, oh, well, maybe it's because when people have maybe more money, it's not just necessarily that they're spending more on their health. Maybe the health care is more expensive, right? It's not necessarily reflecting just quality, right? There's a lot of other factors that would kind of come into play here, but it is kind of interesting to look at some of this data. But pretty easy to create a scatter plot like that. Say, insert, select the type after you select the data you want to graph, right? It's not too bad. We've got our U.S. annual unemployment rate. And then the final kind of thing I'll talk about to end the class here is these different distributions. So we won't really start talking too much about distributions yet in terms of like continuous, but when we create these histograms, they give us a really good idea about what the distribution of the data is. So here, I basically just did a histogram, and this was for SAT scores. So you can see that most schools, the average SAT, and I think it was on the writing portion or something, is somewhere around, 500, and then it kind of tapers off in either direction. Later on in the semester, we'll call this type of distribution normal, or kind of the bell curve. We'll talk about this a lot. We'll be analyzing this a lot. But then we have some other types of distributions as well. So here's income. Notice they have like this catch-all category at the end, and they chose way more than 20 bins, which you can already see. It gives you a little bit finer of an idea, but it just takes a little bit more work when you have that high number of bins. So here we would call this right skewed. It has a long right tail. The majority of people are making what? Between, it's kind of hard to read. These are like $25,000, $30,000. And so the majority of people are making lower amounts. And then you kind of have this long right tail where there's not near as many people at these higher amounts, right? We call that a right skewed distribution. And we also have left skewed. So you think about something like length of the pregnancy or the weeks of gestation. Obviously, we have premature births here that can occur, but once you get to like 9.5 months, we're not seeing any children born at like 11 months, right? So there's a long left tail, short right tail. And it might seem kind of counterintuitive, but we call this left skewed. Even though the majority of the data is on the right, it has a long left tail. Okay? And we'll talk a little bit more about why it's called left and right skewed next week when we start to talk about things like means, medians, and modes. Okay? And the final one is bimodal. And this one's kind of interesting to point out because it reminds us that no matter what data we have to think about the data prior to just like creating some type of a histogram, right? So if I look here, this is actually body weight, right? Why do you think it looks like there's almost two normal curves here? Yeah. Yeah, if I separated this out by male, female, I would have two really what look like very good normal curves. When I throw all the data together and kind of notice they probably overlap here at the tails, now I don't get quite as nice of a distribution, right? So we have to be careful anytime we see like a bimodal distribution. We probably should be thinking there's some characteristic in this data set where if I separate the data by it, I'd probably end up with like two normal curves. Right? Okay, so that concludes for the day, for the first week. I want to see if there's anything in the chat here. For entering the data, will we have to do it manually or faster way? Do we have to save our Excel sheet and turn in? So I think, Mark, you're asking about the individual assignment. Yeah, so for the individual assignment, a lot of people have emailed me about what topic they want. If you can find the data yourself, that's fine. But I've sent out quite a few data sets at this point. If you let me know what topic you're interested in, I can quickly get you a data set probably that works for it. And if you have asked me and I haven't got you one yet, I'm working on it. It was probably one that was a little bit harder to find or maybe something that's close to that topic. Also, when you do submit that individual assignment, right, and it's not due until next week, even once you have the data, it should be pretty easy, right? It's basically like we did today. You don't have to build a whole histogram. You could just use the built-in histogram tool for that first individual assignment, okay? Or create a time series graph. But yeah, when you submit your assignment for that, upload both a Word document, and if you did your work in Excel, you can copy and paste the graph into Word, or you can just upload the Excel file as well. So you can upload multiple files. Okay? Any other questions before you guys get out of here? I know that was a lot for today. I went through it pretty quick. If you have any questions, once I get that first Excel assignment posted next week, probably on Monday, is when I'll post it after class, once we work through a little bit more Excel stuff Monday. Feel free to email me, ask me questions on it. Other than that, get me your individual assignment ideas as soon as possible so I can get you some data so you can complete that assignment. All right? Yeah. I probably won't post one for today, but next week we'll likely have one every single class. Yeah. And if I do post one on a Friday, you still have till the next class period, so you actually have all weekend. Right? I'm not going to post them today, but when I do, probably next Friday, that'll be the case. Okay. All right. Have a good weekend, and I'll see you guys next week. Remember, group 2, you'll show up Monday and Friday next week. Group 1, you guys only show up Wednesday. All right.